So I will do some more questions from moment of force, and then we'll start with the questions from elasticity. It says what is meant by center of gravity. Definitions are very important. It's a point where whole weight of the object appears to act for any orientation. Now we have a square board that is being fitted on a wall. A point and B point, these are the 2 points where it is fitted, and we have a rope attached at C. The force of the rope is 54 newtons and the angle is 35 degrees. They ask us to find the value of vertical component of the tension. So tension will have two components, vertical and horizontal. The 35 degrees is with the horizontal, this angle will also be 35 degrees. So my vertical component is 31, which is 54 sine 35. Explain why the force on the sign at B does not have any moment because it will be passing from the pivot at A. It will have no moment because if the force passes from A, in that case, the moment of that force will be zero. So if it is vertical force upwards, as we had discussed in some of the cases earlier, it is passing from A. So as it is, it will have no moment as its perpendicular distance from the pivot is zero. Okay, by taking moment at A, we have to find the value of W. If we consider W, it will be passing vertically downwards. So its distance from the A will be half of 0.68. Tension will have two components, vertical and horizontal. Both vertical and horizontal component are at a distance perpendicular from the pivot A. Both of them will be creating anti-clockwise movement. Only weight will be creating clockwise movement. 31, if we draw the line of action, it is 0.68 from the point A. 44.2, if we draw its line of action, it is 0.68 from the pivot. W will be passing from the center of the sign board. So it is halfway. So it is 0.34. Using this, we can find out the value of weight. Calculate total vertical force exerted by the wall on the sign at points A and B. Total vertical force. Upward forces should be equal to downward forces. F vertical plus 31 should be equal to weight. Weight we have already calculated. So F vertical will be 150 minus 31, which comes out to be 119 newtons in this case. Then they say that a nut falls from the rest, covers a distance of 4.8 meters, hits the ground with a speed of 9.2 meters per second. Change in gravitational potential energy and kinetic energy, mgh divided by half mv square. We know h, we know v. M and M cancels out, so we don't need the mass of the nut in this case. Simplify that, M and M cancels out, and we can find the ratio. It comes out to be 1.1 in this case. Next question. We have a beam. There are certain number of forces acting on it, and one of the force of 17 newtons is not perpendicular to the distance. It is at an angle of 50 degrees. And before that, they have asked us what are the two conditions. The conditions are resultant force in any direction should be equal to 0 and resultant moment about any point as pivot is equal to 0. These are the two conditions which should always be satisfied if the body is in equilibrium. Vertical component of tension 17 sine 50 comes out to be 13 in this case. So Taking moment about A, we have to find the value of W. W is at the midpoint. Total distance is 0.35 plus 0.15. 12 newtons is at 0.35, whereas 17 sine 50 is at zero point 0.5 meters, 0.35 plus 0.15. W will be at the midpoint, so it is at 0.25. Simplify, and you get the value of W. Calculate the magnitude of vertical component of the force exerted on the beam by the hinge. Again, the vertical force acting at A, because upward forces should be equal to downward forces. They are not. So there must be a force acting at A. Fv plus 13 should be equal to 12 plus W. W was 9.2. Simplify and you get the value of F vertical. The block is now moved closer to end A. Assume that the beam remains horizontal. State whether this change will increase, decrease, and no effect on the horizontal component of force exerted on the beam by the hinge. In this case, horizontal force depends on the horizontal force of the tension 17 newtons. If the object is moved closer to the hinge, less clockwise movement, so tension will also reduce. If tension reduces, its components will also reduce. So its horizontal component will also reduce. So the force on the range will also be reduced in this case. Okay, one more question. Again, similar question. We have a beam pivoted. Then we have weight. We have 0.3 newtons. And at the end, we have a string, 4.8 newtons. And we have to find the vertical component of the tension. It will be 4.8 sine 30, which comes out to be 2.4. Then determine the W. They have told us that the force exerted by the spring is 8.2. So W, 0.3 and 2.4, all of them will be creating clockwise movement and 8.2 will be creating anti-clockwise movement. Distances are to be very calculated very accurately. We have to consider that this is as a pivot. F will be at 0.5, W will be at 0.6, 0.3 Newton will be at 0.8, and similarly 2.4 will be at 1.2. Simplify that and you get the value of the W. Individual distances are to be accurately calculated. So we have the value of W. Calculate the horizontal component force exerted on the beam by the hinge. It will be balanced by the horizontal component of the tension. That is 4.8 cos 30. Because there is no other horizontal force acting on the object. So this must be the force that is exerted on the beam by the hinge. They have told us that elastic potential energy is 0.32. What is the compression? We know the force. And elastic potential energy is given by the formula half F into E. 0.32 newtons. Force was 8.2. And from here, we can find out the value of compression. This is the formula of elastic potential energy. Next part, they say that the string is cut so that the spring extends upwards. This causes the beam to rotate and launch the block into the air. The block reaches its maximum height and then falls back. Like a projectile motion, it is at a height of 0.09 at A and then it falls back to point B. They tell us that the kinetic energy when it hits the ground is 0.44. What is the decrease in gravitational potential energy? mgh. Mass was 0.3 kg. At 0.3 newtons was the weight. So mgh is your loss, change in gravitational potential energy. Total kinetic energy is 0.044. So it must be moving with certain speed at A as well. The difference between these two values will give you the value of kinetic energy at A. And using half mv square, we can find out the speed of the block at A. Mass 0.3 divided by 9.81. At point A, they must have kinetic energy of 0.017. And from here, you get the value of V as 1.1 meter per second. Okay, जी next देखिएगा. Again, a similar question to that we have done. State what is meant by central gravity. It is a place where whole weight of the object appears to act for any orientation. अभी तो हम elasticity के question पे आए नहीं है. We are doing questions from moment of force. Okay, वो कहते हैं जी what is the taking moment of pivot calculate tension T. तो यहाँ पे T की मैं vertical component निकालूंगा which is T sin 30. 54 into 0.45. 2.4 का डिस्टेंस जो है वो 0.95 है और T sin 30 का जो डिस्टेंस है 0.95 प्लस 0.35 ऐड करूंगा मैं उसके अंदर. तो फ्रॉम हियर आई गेट द वैल्यू ऑफ T. अब वो कहते हैं स्ट्रिंग इज नो लॉन्गर इन इक्विलिब्रियम. वो कट कर दिया आपने. बीम इज नो लॉन्गर इन इक्विलिब्रियम. तो रिजल्टेंट मोमेंट क्या होगा? तो आपका ये एंटी क्लॉकवाइज मोमेंट है, ये क्लॉकवाइज मोमेंट है. सब्ट्रैक्ट कर लें. द डिफरेंस विल बी योर रिजल्टेंट मोमेंट. It says what is meant by elastic deformation. When we say elastic deformation, it means that when we remove the force, the object returns back to its original dimensions. It is called elastic deformation. We have load, we have spring constant, and we have extension represented by E. Hooke's law. L is equal to KE, or K is equal to L over E. Now we have two springs in series. What is the total extension? Each spring has extension E, so total extension will be 2E. And the spring constant is L over extension, that is L over 2E. And if we compare it with the previous spring constant, it will be K by 2. L divided by 2E. LE multiplied by 1 by 2, so that becomes K by 2. If we have two springs in parallel, extension will be half. For spring constant, L divided by E by 2 or 2 times L over E, that means 2K. If we have two springs in parallel and one in series, extension will be E by 2 plus E, which is 3E by 2, 1.5 E. And from here, spring constant will be L over 3E by 2 or 2L by 3E, that is 2K by 3, because L over E can be replaced by K. Now we have given a graph of stress and strain. It is elastic. It has a limit of elasticity or proportionality, and then it starts to curve. We have to find the Young modulus. Definition: stress over strain. Choose any point. We have to find the gradient. You can choose 1. You can choose 2, but not 3. But 2 भी हम choose नहीं कर सकते because 2 also goes beyond limit of proportionality. So we have to remain within the limit of proportionality. So you can choose 1 or anything which is less than 2 because that will be within the limit of elasticity. I choose 1.1, divide by 1 in 10 raised to power. From here I have 1.1, and on the x-axis I have 1, 10 raised to power minus 3, 10 raised to power plus 8. You have to see what are the units that have been mentioned there. So you will get Young modulus by finding the gradient of this graph within the limit of proportionality. Now it has extended from 0 onwards and the stress has reached 2.5 10 raised to power 8. If we unload it, reduce the stress to 0, there will be permanent extension. And in that case, we have to draw a straight line back. Now, straight line back will be how? It should be parallel to the first line. It should be parallel to the first line. So just make a line. This line should be parallel to the first line. Same gradient, and wherever it cuts, that will be your permanent extension in this case. Then we have a graph of stress and strain. This must be a rubber. It is a hysteresis curve. And if you observe, loading and unloading graph has a small area in between. This is the energy which is retained by the substance when we unload it. And they ask us the car moves, the walls of tire bend and straighten continuously. That means it loads and unloads. So some of the energy must be retained by the rubber, and that is why it becomes high temperature, because that energy is retained as internal energy. The area in between loading and unloading is the area which shows the energy which is not recovered. So that is why the temperature of the tire rises as it becomes warm. Okay, we have a graph of force and
Also, just
extension.
you can have to write the above one.
हाँ लिख लें. अब वो कहता है जी कि हमारे पास ये ग्राफ है फोर्स एक्सटेंशन का है, मगर 60 न्यूटन पे आके ये एकदम से यहाँ पे ग्राफ ब्रेक कर जाता है. दैट मीन्स इट मस्ट बी अ ब्रिटल सब्सटेंस. इट मस्ट बी ब्रिटल बिकॉज अगर ये डक्टाइल होता तो फिर उसकी एक्सटेंशन जो है वो अनइवन हो जाती. फिर वो कहता है व्हाट इज द अल्टीमेट टेंसाइल स्ट्रेस. स्ट्रेस इज फोर्स ओवर एरिया. मैक्सिमम फोर्स इज 60 and the area is given to us in the first line 7.9 10 raised to power minus 7 divided, and you will get the value of the stress. Then we have to find Young modulus, and Young modulus is stress over strain, या F into L over E into A. We have stress, we have already calculated that, but we can use the values here. Force 60, extension is 3 into 10 raised to power minus 4. We have length 0.24 and area already known from the first question as well. So this is your Young modulus. Maximum strain energy formula half F into E. Maximum force 60. Maximum extension 3 into 10 raised to power minus 4. Simplify and you will get the value of maximum strain energy. And one more question. A hard ball and soft ball with equal masses and volumes are thrown at a glass window. आपने बॉल को मारा है दोनों को, किसके चांसेस ज्यादा हैं तोड़ने के ग्लास. अब सॉफ्ट बॉल जो होती है, जैसे टेनिस की बॉल है या कोई सॉफ्ट बॉल है, जब वो दीवार को टकराएगी इट विल डिफॉर्म. जिससे हम कहते हैं कि वो कंप्रेस हो जाएगी, डिफॉर्म हो जाएगी, और जब वापस रीबाउंड करेगी तो उसकी वेलोसिटी कम होगी. देयर विल बी लेस चेंज मोमेंटम, तो इट विल एक्सर्ट लेस फोर्स. जबकि हार्ड बॉल जो है वो डिफॉर्म नहीं होती, सो इट विल एक्सर्ट मोर फोर्स ड्यू टू ग्रेटर चेंज मोमेंटम. तो चांसेस ये है कि सॉफ्ट बॉल जो है वो ब्रेक नहीं करेगी, मगर हार्ड बॉल के चांसेस ये है इट विल ब्रेक बिकॉज इट विल एक्सर्ट ग्रेटर फोर्स. अगेन वी हैव अ ग्राफ ऑफ एफ अगेंस्ट एक्स. हुक्स लॉ क्या है? विद इन इलास्टिक लिमिट extension is directly proportional to applied force. F is equal to KE. What is elastic limit? इट इज सिंपल लास्ट लिमिट मीन्स जहां तक आप डिफॉर्मिंग फोर्स अप्लाई करें वो अपनी डायमेंशन में वापस आ जाती है on removing deforming force. That is the limit of proportionality, and elastic limit is beyond that. Then we have to find the value of spring constant. We have force, we have extension, ratio F over E is spring constant. You can choose any value. I'm choosing 7 point, I'm using 8 extension. It is 6.4 here. 6.4 divided by 8. You can choose any other point. Like you can choose a 2 on the x-axis if you want to. I have chosen 6.4 on the y-axis. So this will give you the value of spring constant. Work done, energy stored, half F into E for 6.4 newtons. That is the reason why I chose 6.4 newtons. So 6.4 into 0.08 and you get the value of energy or work done stored in the wire. Now we have two springs A and B. B has a spring constant which is double. If the spring constant is double, extension will be half for the same force. So A has an extension of 0.08. So B will have extension half of that 0.04. So total extension will be 0.08 plus 0.04. So it comes out to be 0.12. What is the spring constant? K is equal to F over E. Force is 6.4 and the system has extension of 0.12. Divide it and you get the answer for spring constant. Okay, let's see another question. Young modulus, ratio of stress over strain. We have two wires P and Q, both have lengths L, forces are same. The only difference is that wire P has a diameter D, wire Q has a diameter 2D. Stress. Stress is force over area. If diameter is doubled, area will be increased by 4 times. Remember that. If diameter is doubled, area will be increased by 4 times. So stress of P will be F over A, whereas stress of Q will be F over 4A. F cancels out, A and A cancels out. 1 divided by 1 by 4 means it is 4. Strain, extension over length. They have same length. What about extension? Extension depends on the spring constant and spring constant depends EA over L. If area is increased by 4 times, spring constant will be increased by 4 times and extension will be reduced by 4 times. So extension of Q will be E by 4, whereas extension for P will be E. Simplify that and you get the answer 1 divided by 1 by 4, which comes out to be 4 again in this case as well. Area has a significant effect on spring constant, stress, and even on strain as well. Okay, we have again definition of elastic potential energy. It is the energy possessed by a body due to its state or deformation, compression, or extension. Interestingly, we have a graph of a straight line of f and x. But how we know that it obeys Hooke's law? If it obeys Hooke's law, it must be passing from origin. But we can't see the origin here. So what we'll do is we'll find the gradient and we will use the formula y is equal to mx plus c and put the values there. If c comes out to be 0, then it means it is passing from origin. So I choose one of the values as 40 and the other value as 20 or whatever value I want. I choose 30 as well. Find the gradient. This is the gradient of the graph. Choose any of the points, use y is equal to mx plus c and find the value of c. It is a straight line, and if it passes from origin, then of course it is obeying Hooke's law. So for C, I choose one of the points and find the value of C from here. If the answer is 0, then it is passing from origin and the answer comes out to be 0. The graph is passing from 0. So in that case, it is a straight line with y-intercept equal to 0. It is obeying Hooke's law. Spring constant. It is the gradient f over e. So choose any of the values as f and corresponding extension, and you will get the answer of the spring constant. For example, 10.4 divided by 40 and you get the answer for the spring constant. You can choose any other value as well. Work done in extension from 20 to 40. Find the work done for 20 centimeters, find the work done for 40 centimeters, and the difference W2 minus W1 will be the extra work done. But distance has to be in meters. 0.4 and 0.2. So this is the work done. In this case, whenever they say extension is being increased, how much work is done? Find the work done for the later extension, work done for the first extension. The difference of their work done is the extra energy to be supplied or extra work done is to be done. A force is applied, extension is 50 centimeter. How would you know that the spring has not exceeded the limit? Whenever they ask such a thing and the graph doesn't show it, always say that if we remove the force and if it returns back to its original dimensions, then elastic limit is not reached. Okay, let's see another question. Young modulus, ratio of stress over strain, एक्सटेंशन ऑफ कॉपर एंड सी निकाल दी हमने, दोनों के यंग मॉडल्स दिए हुए हैं आपको, सेम क्रॉस सेक्शन एरिया एंड लेंथ. So you know that E is equal to F into L over E into A, because E is equal to FL over E into A. So just the Young modulus will determine the value of extension. Put the values in the graph. F, L and A cancels out, so we get EC over ES. 1 over EC divided by 1 over ES. And if we simplify, it becomes ES over EC. We know the Young modulus of both the copper and silver. Put it, simplify that, and you will get the ratio. So in this case, if you observe, copper will have more extension than steel. So force extension graph में copper will have less gradient, because copper will have more extension for the same force. Clear? So copper will have less gradient. One more question. Again, we have force and extension graph. We have spring. It has the original length of 0.08. When we have a force hangs from that, the length increases to 0.095. We pull it down and release it. We pull it down. It is in equilibrium at position X. We are pulling it down. Spring constant. Force and extension graph. F over E. Take any other force. Find the gradient or just take F divided by E for that force. Elastic potential energy is this much. We have to show that position X. Extension, we have to find 0.095 minus 0.08. The extension is 0.04 for the first case. And the second case, for the second case, it is 0.04. And in the first case, it is 0.015. So, extension from 0.040 to 0.15. W2 minus W1. Put the values. इसकी बेटा जो क्वेश्चंस हैं I'll take the pictures and I'll post it so that you complete the remaining questions. ठीक है? Time I think is almost over.